Okay, so today's lesson is going to be kind of brief. I forgot to record first two classes, so we're just going to do this thing now. There's a few styles of questions that we'll work on today, and I've also got the two rules that I'll be referencing, and you may want to write these down on your paper if you're at home. Rule number one is if there's a positive 1 in front of the parentheses, then you can drop these parentheses with no changes. Again, this positive 1 is in front of the parentheses. Now, if there's a negative 1 in front of the parentheses, then when you drop those parentheses, you will change all the signs. That's just the two basic rules we're running into. And so here's our first example again. You can see that we have kind of an understood positive 1 here and an understood positive 1 here. And we can think about it as distributing, multiplying each thing by a positive 1. There's no change when you multiply by positive 1 here also. So that's why we say there's no changes to any of these signs or anything. So we can just rewrite the polynomial with no parentheses at all. When everything is plus 1 in front, it becomes like a collect like terms question. And I spend a little time during the classes discussing which do you pick first, because when we do this, I like to start the arrangement. So the highest exponent is a 2, and it has a match, same letter, same exponent, so we can add those coefficients. Second would be the x to the 1 power. Since it's an understood 1, they would match together, and we would add the coefficients together, -3 and +10. And then thirdly, we would include these constants. And then when we do it in that order, since these have no x's, they're last, the constant will always be last, and it's automatically in descending order or standard form. So 7 and +2 make 9x squared. These two, 10 minus 3 is 7x's, and then the constants trailing at the end make 9, and we have our simplified addition problem. There's more discussion during class, and I ask more questions like which one would go second, is there another one that goes with it, which one, and I'll ask a kid or throw the ball at them, and they can answer, and they catch the ball, things like that. All right, and this is basically the same question, except question style, it says the word sum. So we're going to add this polynomial with this one. It'll just come to them in a word form. So they have to understand it's really a problem like this. 8x minus 2 plus -3x squared minus 7, even though the format it originally appears in is just these words. And the key word there will be sum. And again, they could just drop the parentheses. We go through the whole discussion again a second time. This is an 8x minus 2. You can put the plus there or not. That's a -3x squared minus 7. This one's a little more curious with the ordering, because this is 2, that's 1, these two are none as far as the number of exponent on the x's. This one will go first, but there's nothing to add with it. So that kind of stumps some of the kids sometimes for a minute. Same thing happens here with the x to the first powers. And then lastly, we have our constant. So -3x squared plus 8x. And then we have to talk again. Why do we know that's positive? If there's nothing there, it's an understood positive, so we use a plus. And a -9. And then again, we have simplified this question as well. So we did something like that in class, again, with a lot of discussion. This one is where we run into that other rule where we have a -1 in front of that parentheses. This one is just a +1. So the first set of parentheses we can drop with no issue. This second set of parentheses deserves a little more attention. This is negative right here. So it turns into a positive 10x squared. This is a positive, it turns into a negative. Whatever was after that negative, you've got to change the symbols. This one stays the same. There were no changes because of that positive 1. And at this point, it just becomes another collect like terms question. We find the things that are alike. I say, look at these highest exponents. Does it have a match? The x squared, there is a match. This one does not have a match. And then thirdly, the constants trailing behind again. Now, another interesting facet that gets the kids thinking on this problem, and they'll run into this a couple times in the assignment online, is 10 minus 10 is 0. A lot of kids they'll either put 0x squared, because 10 minus 10 is 0, or they'll put 1x squared, or they won't put the 1, they'll put x squared. And they're like, but look, there's nothing there. I'm like, but if you're putting something there, there is 1. And here, it's really 0. They know that, so 0 times x squared, they want to put that x squared there. They have a problem knowing that this really means there is nothing there. Nothing. 0. So we can skip. These actually wipe each other out. They're effectively 0, and 0 plus whatever has no influence, so we just have 2x, and then these go together. They would be third, but they're actually all we have, so they're second. Then we have our final answer. So there's some interesting discussion points with this example, and then we'll see some things adding up to be 0 on the assignment. This is the one where I pause and no, actually we did a second example of the same thing. They distribute this negative, change all the signs because of that negative 1. This is a positive 1. You get negative 3x squared. This one was positive. You have to know that that's a positive embedded inside that parentheses. Now it's negative because you change everything. This is positive, it becomes negative. Whatever it was before, it's the opposite sign. This one, it all stays the same. Match up the things in order. The constant is last. Negative 8x squared from those two. These 4 minus a 1, that's a 1 there. Minus 1, so you get positive 4x. And 5, negative 5 is last. And we're good to go. The last question, I freeze the class and I say, go ahead and try and write this out. Just have like some parentheses, and put what you think goes there. And I just encourage them to write it down or try to write it down. So I want them to make the mistake after thinking about it, because then when I provide the rationale for it, it usually helps aha instead of me just giving it to them. I've taught this before because we actually wrote something like this in a word problem with inequalities, a translation stuff, but it was probably 4, 5, 6 weeks ago, so many have forgotten. But if you're subtracting this from this, the order gets rearranged because you're actually taking this away. So the taking this away is taking it away here. So this is what's subtracted. If you're subtracting this from this, you have to start with that and then take that away. Another way of looking at this is subtract this. So minus this. That's why it's in that spot. And 2x squared plus 7. You know, there is, I guess I could do it another way. They could say minus in front of all that. And it would end up working out the same. I didn't think about talking about it like that in class. Maybe that would have helped them. This one you would drop the parentheses, it would be the same. This one you would change everything, and you collect like terms, and you'll get the same answer that I will when I work it out the top set. So if you're at home and looking at this, you could explain, say, subtract this means there's a minus in front of that. That might actually be easier for the kids to understand. I will think about that in the future. For sure. Okay, So this one has an understood positive in front. This one has the subtraction 1 in front, so this stays the same. And then some teachers say put a plus and then rewrite this again, but rewriting this, all this means change this. So this is now positive 2x squared. That's a positive 2x. That's a positive 7. And we add up the things that go together. This one is by itself solo, and the constants will take up the rear there. The engine is 4x squared plus 2x plus 14. It's like a train, and these are the connectors. But that's the final answer. That's our lesson for today in a nutshell. I probably took 3 times as long as that with the students going slowly, but then they worked on the Delta Math assignment, and that's where these problems were pulled from. Have a good one.